Example solving an isochoric problem. A well-insulated rigid tank contains 3 kg of saturated liquid water at 40 degrees C. A resistor drawing 10 amps when 50 volts are applied is placed in the tank to heat up the water. Determine the final temperature of the water in the vessel after the resistor has been operating for 30 minutes. Same four-step problem-solving procedure. Identify system, process, substance. Fill the table with properties. Determine work. Apply the corresponding first law. From the problem statement, we can identify that this is a closed system. Since the tank is rigid, volume will not change. And when volume stays constant, the process is known as the isochoric process. The substance specified in the problem is water. Since the problem is well insulated, this also implies that my Q will equal to 0. Step 2. We need to find all of the properties in the table, all of the missing ones. For state 1, from the givens of the problem, we know that the phase is saturated liquid with temperature at 40 degrees C. Since the system is closed, the mass will remain constant for both states at 3 kg. From the saturation temperature table, for state 1, we can then find the rest of the missing properties. And since the process is isochoric, volume for state 1 and 2 are the same. System is closed, masses are the same. Since both volume and masses are the same for both states, my specific volumes will remain the same as well. However, as of now, there is only one intensive property for state 2, and there's another one missing. And therefore, there's not much we can do for the rest of the properties for state 2. So this is all we're going to do for now and move on to the next stage. Step 3, we now need to find work. This is the isochoric process. Volume is constant, so there's no volume change. Therefore, my boundary work is equal to 0. No paddle wheel in the system, so my work done by the paddle wheel is 0. Voltage and current were specified in the problem, and we can find the electrical work by applying this formula: voltage multiplied by current multiplied by time. Quick reminder, electrical work is always negative. My time needs to be in seconds. I need to convert the unit into kilojoule by dividing my final result by 1,000. Plugging my numbers, I will have my electrical work at minus 900 kilojoule. We're ready to apply the first law. Since my tank is insulated, Q is equal to 0. Plugging in what we found into the first law. Q equal to work plus changes in internal energy. The only work we have available is electrical work, which is equal to minus 900. Mass is 3, as you can identify from the table. We do not know what U2 is, but we will know what U1 is right here. What's in red are what we can then find. Take a look at the first law. The only unknown we have in the first law is U2, and we can solve for it. Once we solve the U2, which is equal to 467.53 kilojoule per kilogram, we now have two intensive properties, V and U, and we can use the values of U and V to find my final temperature. The phase happened to be a compressed liquid, and my final temperature happens to be between 110 and 115 degrees C. I just want to show you how the PV diagram and the PV diagrams are drawn. State 1 and State 2. State 1 is a saturated liquid. State 2 is a compressed liquid. The volume or the specific volume both stay the same. The temperature has gone up from 40 degrees C to about 110 degrees C and is going up in a straight line. So an isochoric line in the TV or the PV diagrams will show up as a vertical line, as indicated by these two arrows.